All right, so all of these warm-up problems were chosen specifically based on questions I was getting last week on the assignment for this. And it comes down to understanding the information we talked about the isosceles and the equilateral triangle. Specifically the isosceles, and that was the isosceles triangle theorem stated that if two sides of a triangle are congruent, then the angles opposite those sides are congruent, which turns out to be our base angles. So in the first two where they're asking us to find the value of x, opposite those two sides would be those two angles. So they're telling me that these two angles are congruent. So if this angle is 42 degrees here, what is the value of this angle here? 42 degrees. This is also going to be 42 degrees. Now that takes me back to the triangle angle sum theorem that says all the angles in a triangle have to add up to 180 degrees. So 42 plus 42 plus x has to add up to 180. So 42 plus 42 would give me 84 plus x equals 180. Subtract 84 from both sides, and what is 180 minus 84? So x would be 96 degrees. But again, it comes down to understanding that isosceles triangle theorem, because if we don't understand that and apply it, we can't get there. And again, these were specifically chosen based on questions that I was getting on these. Number 2, they tell us the vertex angle is 122 degrees and one of the base angles is x. And again, the isosceles triangle theorem states that if two sides of a triangle are congruent, then the angles opposite those sides are congruent. So these would be the angles opposite these two sides. So this angle here is congruent to this angle here. So if this angle has a value of x, what does this angle have a value of? It is also x. So now on this one, x plus 122 equals 180. So when I go to combine like terms here, I have x plus x. So this is 2x plus 122 equals 180. If I subtract 122 from both sides, 2x equals what? What is 180 minus 122? 58. Then that last step, I have to divide both sides by 2. So what does x equal? 29 degrees. But again, I can't say it enough. It starts with the isosceles triangle theorem. And we know it's an isosceles triangle because we see the markings to show that two sides of the triangle are congruent. Now, the second set of warm-up questions here, they want you to solve for x. So now they're going to be giving me expressions that I have to deal with. But again, I need to know the relationships in the triangles. Triangle number 1, now all of a sudden, all three sides are marked congruent. And we learned that that means it's an equilateral triangle. But we also learned if it's equilateral, what else is it? If a triangle is equilateral, it is also equiangular. So if it's equilateral, we know all three angles are congruent. And we said, well, if all three angles are congruent, and we know that triangles always have to add up to 180, we divided 180 by 3, and we said, well, all three angles have to be 60 degrees in. which is great, but that's not what they're asking me. They're not asking me for the measure of the angle. They're asking me to solve for x. In this case, the measure of angle 2 has a value of 5x plus 5. Angle 2 is this angle here, which means that 5x plus 5 is equal to 60, because we know that angle has to have a value of 60 degrees because all three sides of that triangle are congruent. So if I subtract 5 from both sides, I get 5x equals 55. Divide both sides by 5. And what does x equal? 11. But again, I have to be able to distinguish between an isosceles triangle and an equilateral triangle, and I have to know, what does that mean? Number 2, it's an isosceles triangle because I only have the two sides marked, so the angles opposite those two sides are going to be my base angles, and they're going to be congruent. So if one of my base angles is 40 degrees, what is the measure of my other base angle? 40 degrees. This time I know that the measure of angle 2 is equal to 14x plus 2, so that's the value of that vertex angle there. So 40 plus 40 plus the quantity 14x plus 2 is going to be equal to 180. When I go to combine like terms, 40 plus 40 is 80, but I have to remember about that 2 in there, so I have 82 plus 14x equals 180. Subtract 82 from both sides. What does 14x equal? 98. Divide both sides by 14. And what does x equal? 7. So again, I cannot stress it enough that we have to understand those theorems and properties about the isosceles triangle and the equilateral triangle. That is the key here. Now we are moving on today to notes triangle inequality and exterior angles theorem on page 15. Now before we get back to talking about the triangle inequality theorem again, just defining theorem and postulate, which are two ideas that are going to come up. We've already had the triangle angle sum theorem and the isosceles triangle theorem, but just to put a formal definition, a theorem is a statement that has been proved or can be proved. The proof of a theorem is a logical argument that uses deductive reasoning. Deductive reasoning is where you use what you know to make educated guesses about things. Like when we did the triangle angle sum theorem, we started with a triangle, we translated it in two different directions, and then we did a rotation, and we showed that all three angles never changed size, and yet we could show that they added up to 180. Okay, so we did that was an informal proof. And the difference between a formal proof and an informal proof is the structure in which we proved it. And a postulate, and postulate is going to come up in a couple lessons here. A postulate is a statement that is assumed true. So if they give us a postulate, we're allowed to use that information without having to be able to prove it or show anything else. It's just accepted as true. Now on Friday, I gave you some spaghetti and some dice. And you broke that spaghetti into certain lengths, and then you rolled the dice to see what length you were going to contribute in your group to see if you guys could make a triangle with those specific lengths. And at the end of the exercise, we came up with the triangle inequality theorem that says the sum of any two sides of a triangle is greater than the length of the third side. So what that means is A plus B had to be greater than C. B plus C had to be greater than A. And A plus C had to be greater than B. And this is where A, B, and C are the possible lengths of the sides of a triangle. All three inequalities must be true for the lengths to make a triangle. All right, so this first set of examples here, this is really what you were doing with the spaghetti the other day. You were just getting the three sides by rolling the dice to see which piece of spaghetti you were going to do here. So the first one, they give us the values 2, 9, and 10. So one of them is going to be A, one of them is going to be B, one of them is going to be C. And again, all three inequalities have to be true here. So A plus B has to be greater than C. B plus C has to be greater than A. And A plus C has to be greater than B. If we can make three true statements here, then we can say, yes, these can be the side lengths of a triangle. If one of the statements is not true, then these cannot be the side lengths of a triangle. So in this case, 2 plus 9 has to be greater than 10. Well, 2 plus 9 is 11. 11 is greater than 10. That is a true statement. 11 is greater than 10. 9 plus 10 has to be greater than 2. 19 is greater than 2. That is also a true statement. And then 2 plus 10 has to be greater than 9. 12 is greater than 9. That is a true statement. Since all three of those are true statements, yes, these side lengths can be a triangle. But again, don't just stop at one. You have to make sure and check all three inequalities. Number 2, 9, 21, and 10. Again, it doesn't matter which one is A, which one is B, and which one is C. They're just simply standing in for the 3 possible side lengths there. So again, A plus B has to be greater than C. B plus C has to be greater than A. And A plus C has to be greater than B. If I can get 3 true statements, then yes, those values can be the side lengths of a triangle. So the first one, 9 plus 21 greater than 10. 9 plus 21 is 30. 30 is greater than 10. So that is a true statement. The next one, 21 plus 10 has to be greater than 9. 31 is greater than 9. That is a true statement. And then 9 plus 10 has to be greater than 21. 9 plus 10 is 19. Is 19 greater than 21? Nope, that is a false statement. And that false right there is going to provide the no. We cannot have a triangle with side lengths of 9, 21, and 10. All right, number 3, 8, 7, and 15. Again, so one of them is A, one of them is B, one of them is C. A plus B is greater than C. B plus C is greater than A. A plus C is greater than B. So 8 plus 7 is greater than 15. 15 is greater than 15. Is that a true statement? Is 15 greater than 15? No, that is false. If we check the other two just to show you, we would get 7 plus 15 is greater than 8. So 22 is greater than 8. And that is true. And then 8 plus 15 is greater than 7. 23 is greater than 7. That is also true. But again, it comes back to that one false statement that is going to make this a no. So that's one possible way to use this theorem, is to be given 3 lengths and check, can they make a triangle? The other way that this theorem is used is if we have 2 lengths of a sides of a triangle, can we determine what would be the range of values? We cannot determine what the exact value of the third side would be based on this little bit of information, but we can determine what would the numbers it would have to be between to make the triangle inequality theorem true. So it says, example 2, 2 sides of a triangle have the following measures. Find the range of possible measures for the third side. So the first thing I'm going to do is I'm going to say let x equal the third side. And I'm going to put x up there. So I have 12, 8, and x. Because I'm really going to follow the same thing I was doing above. It's just I have one of the sides that I don't know the value of. So I still have my A, my B, and my C in this case. I'm still following the same 3 inequalities where A plus B has to be greater than C, B plus C has to be greater than A, and A plus C has to be greater than B. That is all still the same. So now 12 plus 8 has to be greater than x. 12 plus 8 is 20, so 20 has to be greater than x. Or in other words, what that is telling me is that x has to be less than 20. I have to have a value that is less than 20 in there. And then 8 plus x has to be greater than 12. If I subtract that 8 from both sides, that means that x has to be greater than 4. And you're going to find when you do this, when you're given two side lengths and trying to find the possible range of values of the third side, one of your inequalities is not going to be helpful. And I'm going to show you why. And this is going to happen every time. And it's not always the same inequality. It's just based on the values you're given. When I go to substitute in this time, 12 plus x has to be greater than 8. The problem here is 12 is already greater than 8. So any positive number that I add to 12 is going to make this true. And if I go through the solving and I subtract 12 from both sides, I get that x is greater than -4. The problem there is, can I have a negative side length? No. So this beauty here doesn't tell me anything. When you get a negative value on these, toss it out. It does not help you. Okay, because 12 was already greater than 8, that one is not going to help me. So the values, again, 20 is greater than x and x is greater than 4. So how would we write this out is 4 is less than x is less than 20. So my value for that third side has to be greater than 4 and less than 20 to make all these inequalities work. So the second one, they give us possible values of 9 and 10. So again, I'm going to say let x equal the third side. So I have my A, my B, and my C. Same three inequalities. And now I'm going to substitute in. So 9 plus 10 has to be greater than x. So 19 is greater than x. 10 plus x has to be greater than 9. If I subtract that 10, I'm going to get that x is greater than -1. So no thank you, Mr. Negative Value. You're not going to help. And then 9 plus x has to be greater than 10. Subtract 9 from both sides. And x has to be greater than 1. So 1 is less than x is less than 19. That is the range of possible values for the third side of a triangle given two sides are 9 and 10. Number 6, they're giving us 15 and 3. So again, I'm going to let x equal the third side. So that I have my A, my B, and my C. set up my three inequalities. A plus B is greater than C. B plus C is greater than A. A plus C is greater than B. And now start substituting in. 15 plus 3 has to be greater than X. So 18 is greater than X. 3 plus X has to be greater than 15. Subtract 3 from both sides. And X is greater than 12. 15 plus X has to be greater than 3. If I subtract that 15 from both sides, I get X is greater than negative 12. And again, the negative is not going to help me. So I have 12 is less than X is less than 18. So my third side has to be between those two values. All right, so that's the end of the triangle inequality theorem, but we do have one more theorem that we're going to talk about today. On the next page, we have the exterior angle theorem. The exterior angle theorem says the measure of an exterior angle of a triangle is equal to the sum of the two remote interior angles. So let's talk about what are they talking about. There's a lot of vocabulary here, so I'm going to draw a diagram here. When we're talking about an exterior angle of a triangle, that means that one side of the triangle has been extended beyond. So in the case here, this angle out here would be my exterior angle. And then they talk about, so that's the exterior angle. Then they talk about two remote interior angles. What they're talking about, obviously we know there are three angles in a triangle. They're talking about the two angles that are not adjacent to the interior angle that we are, to the exterior angle that we are talking about. The one that is adjacent to it is the one that shares a side, which means the other two, and in this case it would be this angle here and this angle here, would be our remote interior angles. So the two angles that are not adjacent to the exterior angle we're referring to, we can add those two together and they should be equal to the value of that exterior angle. And that comes from the idea of knowing that adjacent angles, again, we have that straight line, and we said way back in the triangle angle sum theorem that if angles come across a straight line, they have to add up to 180. So if the exterior angle and its adjacent angle have to add up to 180, and the three angles in a triangle have to add up to 180, that means the two inside that are not adjacent would have to have the same value as that exterior. So the first set of examples says find the measure of each angle indicated. Again, this 138 degrees here, this is going to be our exterior angle. which means that these two angles down here, the two that are not touching or not adjacent, these are going to be our remote interior angles. And where they have the question mark, I'm going to change that to an X just to make it a little easier to set up my equation here, because X plus the 106 has to be equal to the 138. Those two angles added together have to equal that exterior angle. And if I subtract the 106 from both sides, what does X equal? 32 degrees. All right, number 8, the 152 here, that would be my exterior angle. Which means angle U here and angle T here are my remote interior angles. And again, I'm going to replace that question mark with an X. So 94 plus X has to be equal to that exterior angle of 152. If I subtract 94 from both sides, what does X equal? Actually, 58 degrees.